Welcome to another episode of the On.NET Show. Today I'm here to talk about the .NET Core 2.1 roadmap. I'm Scott Hunter, Director of Program Management at Microsoft on the .NET platform, and I've got a bunch of folks with me today. I've got Rich Lander, who's going to come in and talk about .NET Core and the SDK and the CLI. I've got Daniel Roth, who's a Program Manager on ASP.NET, and he's going to talk about what's new in ASP.NET. And I've got Andrew Peters from the Entity Framework team, and he's going to talk about some of the new advancements we have in Entity Framework 2.1. And we're going to let Rich, Dan, and Andrew come up and do some demos and show you some of the 2.1 features. Thanks.
Okay, so I've got two demos that I'm going to show quickly. One is I wanted to show our global tools new feature and how that works. So here I've got just a regular app. It's just a regular console app that I've just created. It only differs in one small way, which is it's got this new this new project property called packAsTool equals true. And then basically what I do is I pack my application. Not entirely sure why all those warnings are there, but that doesn't matter. I'm going to pack the application as a NuGet package, and then I'm actually going to .NET install this particular app. Normally, the flow I'm showing you is when everything's on my machine. Normally, the developer and the consumer wouldn't be the same person. The developer would post to NuGet.org, publish some kind of documentation somewhere, and then people would know to type this on their machine, and then .NET install tool test app would actually go to NuGet.org, but we're not doing that at the moment. Then I can type, oops, so you have to type it correctly. So then I can type test app. You don't have to type .NET test app, and just to kind of, actually there's no D drive on this machine, but and then just to make the point, you know, I can type it anywhere on my disk, and it works. So this app is actually in the path, and just to show you how this works, we actually added a new directory to the path. It's in your user folder .NET/tools, and that's where all the tools will go. So it's a great new feature. We expect it to be super popular. And then one other thing I wanted to show you is our .NET Core Compatibility pack. We did a blog post on this in November, and we actually had some sample code that I was looking at here. I wanted to figure out how to really quickly come up with a demo. So registry is one of the new APIs that you can use, and if you see here that we have this long list, you can see it's actually the very first thing is Microsoft Win32 registry. It's available and it's Windows only. That's kind of what this is telling you. So what I decided to do, very simple demo, is I decided to go to GitHub. GitHub is this awesome feature where you can search on code, and so I went to the code segment and I decided I'm going to take the very first piece of code here. So I'm actually going to grab the entire class. And then I'm going to go to Visual Studio, and I'm going to, I'm going to add a class. We'll call this the I hope this works.cs class, because actually I guess this is going to erase everything now that I think about it. So I'm going to copy and paste everything. And you can see it's not working, actually, which is super unfortunate. I was hoping this was going to work, and it's not, because we see all these red squigglies. But in fact, if I go back to this blog post, you'll see that it actually references somewhere. Yeah, it references this NuGet package, which takes you here. So this is the NuGet package that has all the good stuff in it. So we copy and paste that. Go back to Visual Studio, go to, say, Manage NuGet Packages. You can see I've done this before. So I'm going to quickly install this NuGet package into my project. Wait while NuGet does all the good stuff. And then I go back to my class, and all the red squigglies are already gone in this whole file. So this file, previously, as of .NET Core 2.0 release, would completely not work on .NET Core. By virtue of just adding this NuGet package, everything works now in this file. So I'm super happy about that, and hopefully that developer is happy as well. Okay, that's all I wanted to show today for .NET Core 2.1 runtime and .NET Core SDK features. And now I think Dan is going to come up and show you some new features in ASP.NET Core.
Hi everyone, I'm going to show you what's new in ASP.NET Core 2.1. So the first thing I want to show you is SignalR. SignalR is coming to ASP.NET Core. It's actually already available in public preview. If you want to try it out today, you can do that. The packages are available in preview form on NuGet. If you want to try out the sample that I'm going to be showing you, I would go check out this repo on GitHub, the SignalR-samples repo in the ASP.NET org. But here I've already got the project open. This is a ASP.NET Core SignalR app. Here's my hub. It's a shape hub. What this app does is, actually, I'll just go ahead and show it to you. Let's pop up Edge with the app. Let's pop up IE, and let's get Chrome going as well. All the browsers. You get a little red square, and you can drag and just move it around, and it moves in all three browsers in real time. And that's done through the magic of SignalR. If we look at the code, here we have our hub. It has a move shape method on it that receives the notifications from the SignalR client saying that the shape has moved, which it then broadcasts to all the connected clients, except for the client itself that triggered the original event. That's the hub. If we look at the JavaScript code in the HTML file, this is what the clients look like. They have a hub connection that they listen for the shape moved event, so they know where to move the square. And then if the shape moves in that browser itself, then it sends that move shape event to the server. Super simple, super clean. And you'll notice that this JavaScript client has no jQuery dependency. It's just a pure JavaScript client. It can be used from TypeScript as well. So that's SignalR. You can try it out yourself. Try it out today. Next, let's go to, this is an app that I just created from the default new templates that we're working on for 2.1. This is a Razor Pages app that I enabled individual user accounts. Let's just go ahead and run this, and let's take a look and see what it looks like. Let's make the browser big so we can see it. All right. So first of all, you'll notice that it's initially going to HTTP, and now it just bounced over to HTTPS for me. So HTTPS is enabled by default. You don't have to do anything. We get nice, secure visualizations in the browser. If we go look at what the app does to enable that, if we look in Startup CS, let's look in the middleware pipeline. Down here, you'll see there's the HTTPS redirection middleware that's built in that will handle bouncing HTTP requests to HTTPS. We also add HSTS support. This is the protocol that allows you, the website, to ask the browser to enforce that the site is always accessed using HTTPS. So HTTPS built in by default. The templates just have it enabled. You don't have to do anything. Also, if I take this this site, I've already browsed this site a couple times, but if I go in a new window, like a new incognito window, I see the same app, but now I get a little notification bar at the top telling me about this site's privacy policy, and I can decide, do I want to accept this or not. So we give you a pre-canned UI for dealing with cookie consent. We're also enabling features and identities so that users can be deleted and that they can export their data for European Union GDPR compliance. All right, so we do that. Well, let's see, what else is here? I've added a little bit of application logic to this app. It already has identity wired up. You notice I can register new users, I can log in new users, but you'll notice that the app in the Pages folder, like there's no identity code here at all. Like there's no accounts folder, there's no managed folder. That's because identity is being added to this app as a package. Like we can search for that package. There it is, this Microsoft ASP.NET Core identity.ui. It's just there and it's pre-built. I don't have to have the code in my templates if I don't want it there. To enable that in the application, it's just one line of code. Add the default identity UI. So identity as a package. Just add it to your apps and you can get identity. It's just that simple. Now I added a little pets page to this app so I can see all my wonderful pets. This is just a simple scaffolded page. Lets me add, remove, and edit pets. But it's backed by a web API. I built a pets controller for managing all my pets. So, pets as a service, I guess. So if we look at that pets controller, you'll see this looks like a normal ASP.NET Core controller for building an API. We've got a GET request to return a list of pets. We can get individual pets if they're not there. Excuse me. We'll return a 404 not found. We can create new pets. And when we do all the right stuff, like we return 201s with location headers and so forth, we got to check the model state to make sure it's valid. These are all the things that you have to do today. We're trying to make this simpler though. And actually, let's take a look at how this API appears when you see its Swagger document. I've enabled Swagger already in this application. If we look at the Swagger document for this app, get looks pretty reasonable. It tells me that the response will be an array of pets. That looks fine. If we look at some of the other ones, like post though, I can see the structure of the request, but I don't get anything about the response. I don't know what it will return in the response, what error codes it will return in the response. I can add that information by adding attributes, but wouldn't it be nice if it could just figure that all out for me? So what I'm going to do to this API controller is I'm going to add some web API conventions. I'm going to add this API controller attribute, which enables these conventions. And I've actually got a new analyzer that we've implemented that will let me know about all the places where I can improve this controller and make it to make it simpler and make it more descriptive. So for example, let's see, in this get action down here, I'm getting some sort of warning. Let's take a look at what that says. Oh, it's saying that I can now update this action to return a new action result type called action result of t. Can you see that? Let me zoom in a bit. Action result of t. So that's a convenient thing to return that's explicit about the structure of the response, but it still allows you to just return action results or even return the t itself. It will do the type conversions for you. So that sounds nice. So I'm just going to go ahead and do that one. All right, so there, action result of t, now enabled for my get action. What else? Oh, so in the post action, that model state is checking if the model state is valid. I'm getting something there. It looks like, well, with that web API convention, we will now check the model state for you. There's basically a filter in place that will automatically return with 400 error responses. Those error responses will be formatted with a standardized format called problem details. It's an RFC. So we can remove this code now. We don't need it anymore. So let's just go ahead and accept that. So we remove the validation logic. Again, we can use action result of t here. Let's go ahead and do that. And let's improve the descriptiveness of our application. We can remove that as valid check because we don't need that. Let's use action result of t here. It's a nice analyzer. It makes it really simple to do these refactorings. Okay, and that one, yeah, action result of t there as well. So now the delete action, you also know it returns a pet. If we save that and then go back to the Swagger document, let's see what we got. Did we get something better than we had before? Okay, so get looks the same, yep. And then post. So post now, we're getting a whole bunch of information about the response. We now know the structure of the response. And we're getting a whole bunch of information about potential error codes that the post action could return. Like it could return a 400 bad request. And this is the structure of that problem details format that I talked about. So the clients can just look at this and know what will happen in the case of an error condition. So that's super nice. All right, so that's the new web API conventions. Now, of course, if you have a web API, you're going to want to call it. And that's where you can now use that HttpClientFactory that we talked about earlier. Let's take a look at calling a web API. So if we go back to the app, let's look at the index page of the pets part of the application. And let's see, let's go to the page model. Here's the page model, super simple. You can see it's just getting a pets client that's injected into the page model, and it's using that to then get the pets. Okay, that looks simple. What is this pets client? Well, this is a little client that I wrote, but you'll see that it takes an HttpClient in the constructor. So HttpClient with the HttpClientFactory is basically available as a service. You can just get it injected from DI. And then I just use that HttpClient to implement a bunch of convenience methods for accessing the web API. And it's already configured. It already knows what the base address is. How did that happen? Let's take a look at the startup class and see how we configure these HTTP clients. We go down here into the configure services method. Here you can see services.add HttpClient, and you can give them names, so you can have different configured HTTP clients. I'm already setting up the base address here. It's coming out of config, so you can flow configuration data from like app-settings.json into your HTTP client instances. And then I'm even adding that typed client, that pets client, so that it can be available from my page model as well. So that's the HttpClientFactory. That allows you to configure these HTTP clients. But what about cross-cutting concerns like retry logic? Let's add a little bit of randomness to our web API. I'm going to go back to the get action, and I'm going to uncomment this line of code, which what this will now do is every other time you call the get action is going to fail. It's just going to blow up. It'll return, return a 500. So if we go back to the app now, okay, so we're going to go to the app, and now every other time that I access my pets, I'm expecting it to fail. Yeah, so there, like the first time I access it, if I refresh, it works. If I do it again, it fails. Okay, and that can happen, right? You could have random network errors. So what we're going to do is add some retry logic. It'd be a royal pain if everywhere in my app that I made an HTTP client call, I had to add that retry logic there. So to do that in a centralized way, in the startup class, I'm just going to add a message handler for my HTTP clients that adds a little retry handler. So that's a simple little message handler that just tries 5 times and puts a little pause in between. So now all my HTTP clients get that retry logic. You can deal with these cross-cutting concerns in a centralized way. So I think I just saved that. Yeah, it looks, nope. Let's make sure we save this. And that should cause the app to rebuild. And now if we go back to pets, wait for the app to rebuild and re-render. And it's trying, so it should get that initial failure, and then it'll try again. So now if I keep clicking on pets, every time that I click on it, I'm just getting the successful page. I mean, every other request there is actually failing, but because of the retry logic, it just works. So those are some of the new things that are coming in 2.1 for ASP.NET Core. And next, we're going to take a look at EF, and we'll have Andrew come up for that.
Okay, hi everyone. I want to show a few quick demos on what's coming in EF Core 2.1. So first, I want to talk a little bit about lazy loading. So here I have a little program. It's basically a small blogging context. So I have a bunch of entities, blog and post. Let me show those. Down here we have a blog, and it has a collection of posts. Also has a blog ID, a name, and a URL. Now my context. Pretty normal. I have 2 DB sets, blogs and posts, and then a little bit of on configuring just to set it up to talk to SQL Server. What does our program do? So it's just going to run through the blogs and then print out any posts the blog has. So for each blog and blog, write the blog URL. If the blog has any posts, write the posts out. Let's run it. Okay, so you can see here we're printing out the blog URLs, but currently there's no posts. And this is because we actually haven't loaded them. So typically the way you would load them with the EF pre-lazy loading is you use an API called include, and that allows you in the query to say that you want the posts included when the blogs are returned. Lazy loading allows you to defer that so that when you access the post navigation property, they will automatically be loaded for you. Let's see how that works. So down here, I'm going to enable lazy loading. Now in 2.1, there will be APIs that you need to put in your entity types to make this happen. The second part of lazy loading, which will happen post 2.1, is that we will automatically do this for you at compile time. So right now, we're just getting started with the APIs and the patterns. I'm going to uncomment that. So now you can see I'm just tweaking the definition of the post navigation property, and I've got this lazy loader field here. Now what's this lazy loader field? This is actually a delegate that EF Core is going to pass into the entity when it's created. So this delegate is a way to call back into EF Core in a really loosely typed way that doesn't couple you too much to EF Core, but what it will provide is essentially a service that knows how to load the navigation property. So we say lazy loader.load. We pass the instance of the entity and a reference to the posts field. Run it again. You can see now we're getting the posts listed out. So EF Core underneath has pulled back the posts for each blog as it was accessed in that for loop. Okay, so that's lazy loading. Second demo I want to show is what we talked about earlier for CosmosDB. So this is all about leveraging your knowledge of EF Core, the APIs that you already know, to be able to talk to different data stores and non-relational data stores too. What does our program do? We have a blogging context again. We can create the database in Cosmos. We can add data to it. So we're adding the blogs. And then we can run queries over it and even change the data and save it. So I'm going to jump over here. This is I'm running against the CosmosDB emulator. And we can see here that currently on my machine there are no databases set up. So it's empty. So let's run this. Actually, first I'm going to quickly show how you enable this. So this is just using our standard configuration patterns. So we have this new API, use document DB. And this is essentially bringing in the CosmosDB provider. Here you can see you specify the endpoint, some token, and the name of the database. So all very familiar. Let's run it. Okay, you see we've got the database created, we saved 6 records, and then we queried them, and then we loaded some posts. Let's jump over here and see what we've got. Cool, there's the database. Love this emulator, by the way, it's super fast. Blogs, we can look at the documents. We have 4 blog documents, we can see the JSON in here, and then we can look at the properties that EF's put in there. We've got an ID, we've got a foreign key, and we've got a discriminator even, because in this example we're using inheritance. We have blog, and we have a subclass, special blog. I think number 4 is the special blog, so we should see the discriminator is different. There we go. And we can see the posts. We have 2 posts linked to blog 1. There we go. I think this app wants me to create another post, so I can press any key. Adding a post to blog 1. Let's refresh. Okay, there's a new post. So if we jump back over here, we can see what we did. We looped through the post, normal EF APIs. Here we added a post, and then we just called save changes. Now the CosmosDB provider for EF is calling through to the DocumentDB APIs, it's getting the JSON together, it's doing all that stuff, managing the unit of work pattern, surfacing link view, and it should allow you to leverage all of the skills you have and the APIs you know to start lighting up in your application some of these cool cloud-based data stores. Thanks a lot.
So you've just seen some awesome demos from Richard Lander on .NET Core, Daniel Roth on ASP.NET Core, and Andrew Peters on EF Core. I want to jump back to the schedule real quick and say we hope to have the first preview of .NET Core 2.1 available sometime in early February. I've got the rest of the roadmap here. And I just want to say thanks for watching, and look out for the next version of on.NET.